Hello everybody, I'm Yu Tingting and this is my paper, Training Wheels for Mixed Models. And I'm a statistics in Westchester. Thanks for my co-author, Mr. Ross. For this paper, we have 9 sections. First is model history. Second is one-way fixed ANOVA. I calculate by hand, also calculate by hand. And the fourth one is one-way fixed ANOVA. I use proc ANOVA and proc mixed. I will contrast the results. And the fifth one is one-way versus two-way fixed ANOVA. I use proc ANOVA, and the second variable will reduce some square of error. The sixth one is one-way fixed ANOVA. I use proc mixed. I will show you the matrix formula. The 7 is two-way fixed ANOVA. I use proc mixed and also show you the matrix formula. The 8th one is introduction to random variables. And the last one is two-way mixed model. One is fixed variable and another one is random variable. I will use proc mixed, and matrix formula for mixed model. Let's go to the first one, model history. The thread I will follow is an error using a data process to repeat to its mean. Let's get a very quick overview of the model history. We have 3 models, regression, ANOVA, and prognostic. For the prognostic, we have Poisson, binomial, and exponential. All of them together, we can use prognostic. It's generalized model. For another part is mixed model. We have fixed variable and random variable. We use prog mixed. And both of them is prog mixed. This is our mixed models. So to build reader context, we will compare and contrast results from several of these procedures. I will go too fast as the paper has more details. Let's go to the second section is one-way fixed ANOVA. I calculate by hand. The thread I will follow is as error is an ability of process to repeat to its mean. This is our story. We randomly assign 6 stores to each of 3 salespeople, Ross, Joe, and Bo, and record dollar sold. We will partition the variability in dollar sold. Just follow the red arrow. The long red line represents total variability. Total variability is caused by observation being different from overall average. We will partition the total variability into 2 parts. Variability caused by the group average, not being the overall average, and variability caused by the observation not being on the average of this group. And each of these 3 people or processes has a mean and a standard deviation. Think of 3 processes generating data. We assume that the 3 salespeople are equally effective. With evidence, we can conclude the salespeople have different sales abilities. This is our hypothesis. Assumption. H0, mean group 1 equals to mean group 2 equals to mean group 3. HA, at least 2 groups differ. If H0 is true, we all have the same sales ability. Just look at black distribution. This is another one. For the first one, Bo was lucky this day. For the next one, Joe was lucky this day. On the right side, we see there are 3 curves. First condition is all 3 curves are different. A second one is Ross and Joe are bad and Bo is good. The third one is Joe and Bo are good and Ross is bad. So sum square total sums the difference between an observation and the overall mean of the whole data set. So sum square total is variability is compared to its overall mean. This is our formula. And 7 is observation for the first group. 20 is the overall mean. And sum of them equals to 1,794. And this 16 is the second observation for the second group, and 20 is the overall mean. So this is the same. Just follow the black arrow. And the thread I will follow is that arrow using ability of process to repeat to its mean. Sum square between groups sums the difference between group means and the overall mean of the whole data set. Sum square between groups, variability is compared to overall mean. This is our formula. 9 is a group mean for the first group and 20 is overall mean. Sum of them equals to 1,764. So sum score within groups sums the difference between observations and their own group means. This is also called sum score of error. Sum score within groups variability is compared to group averages. This is our formula, and the sum of them equals to 30. Sum square calculations are always comparing to a mean, but means can differ. Now we can say 18 is observation for the second group, and the second 18 is our group mean for the second group. 35 is the observation for the third group, and 33 is group mean for the third group. This is our hypothesis assumption, and this is our lower table. We can know our F value is 512.13, and this is our R square, 0.977. Let's go to the third section, two-way fixed nova. I calculate by hand. So the thread I will follow is the arrow using a better process to repeat to its mean. Are men and women more effective demonstrators? We have 4 men and 4 women in each of 3 cities. We will test in 3 cities and introduce a product in 1 city. Management is very interested in the means of these 3 cities, and so we must call these cities as fixed variables. The thread is the arrow using a better process to repeat to its mean. This is our table. So sales for the 24 stores plus sale means, and in this table we have 6 sale means. First one is Boston, and the mean is 27. Second is Philadelphia, mean is 34. And the third is Washington, mean is 32. In our experiment, we have 24 different stores and randomly assign 4 stores in each city to a female or male demonstrator. We have the ability to measure the sales of stores in Boston, Philadelphia, and Washington. We want to know which city is the best market for our product. In addition, we also want to know which gender, female, male, do much more contribution for the sales. We can see the bottom. The female is 34 and the male is 28. And this is also our hypothesis assumption. H0, mean Boston equals to mean Philadelphia equals to mean Washington, and mean female equals to mean male. And this is HA, at least 2 groups differ. Grand mean is 31. So variability is inability of process to repeat to its mean, and we have 6 processes. Sum square error is sum square difference between observation and the mean of each cell. Just follow the red arrow. Between variability, sum square model, sum square between is sum square difference between marginal average, city or sets, and the grand mean. Just follow the red arrow. We'll show you the main effect of each variable. And this is our two-wheel NOVA model. So total variability is sum square of difference between observation and the grand mean. These arrows are part of a NOVA table. Sum score between groups variability is calculated using group averages and the overall mean. And sum score total variability is calculated using overall observation and overall mean, and sum of them equals to 454. And sum score within groups variability is calculated in reference to cell averages. We have 6 sum score of error. And sum of them equals to 30. We calculated the two-wheel NOVA table, sum score of total equals to sum score model plus sum score of error. It means we can partition our variability. Sum score of total equals sum square of city plus sum score of gender plus sum score of error. Importantly, putting the three cities in as a fixed effect causes us to create output that allows us to talk about city means and reduce some score of error and makes F-test better. Because we have decision to make more these three cities, we call them as fixed. I will discuss this part later in the fifth section. Let's go to the fourth section. When we fix NOVA, I will show the NOVA and proc mixed. This is our data. This is two proxies, same model on fixed X. So first is proc NOVA. And this is output from the SAS. This is our output. And this is proc mixed. This is output from the proc mixed. We can see same statistics but different names. From the ANOVA left side of the blow, we can find the sum square of error is 246, mean square of error is 11.7142. Let's go to the next section, is one-way versus two-way fixed ANOVA. I use proc ANOVA and I find the second variable will reduce sum square of error. This is our data. First, I use proc ANOVA and the city is fixed variable. Next, we add a second fixed X variable to the model to make it predict better. So from the output in SAS, we can see the sum square of error becomes much more smaller, not just 30. R square becomes larger, is 0.933 when we add this new variable sex in our model. Management is interested in the effect of city and sex and report on those. Putting a second fixed X variable will reduce some square of error and makes F-test larger. We'll calculate a fixed variability using overall mean of Y. Let's go to the sixth section. When we fix ANOVA, I use proc limits and I show you the matrix formula. Next, we will analyze a one-way fixed model using plane mixed. The only X variable is sex. So this is proc mixed. We can see this is X matrix. This is our matrix formula. For the first one is our dependent variable. And for the X matrix, the first line is our intercept. And the next line is our sex. This is our independent variable. For example, the first observation is 28.5. We use matrix formula to calculate that. And then this is our predictive value, 34. We find the error is negative 5.5. And this is the second observation is 29.5. This is our calculation process. And this is our predicted value, 28. So we find the error is 1.5. Let's go to the seventh section, two-way fixed ANOVA. I use proc mixed and I will show you the matrix formula. So this is our data. I use proc mixed. And for this proc mixed, I put city and sex in our model. They are all fixed variable. And this is a matrix, X matrix. And this is a matrix formula. This is our dependent variable. And this is an intercept for X matrix. And this city variable. And this sex variable. For example, the first observation is both male and female, and the value is 28.5. So we use the matrix formula. And then we get the predicted value is 30. So the error is negative 1.5. And the next example is about Washington, D.C. for female, and the value is 33.5. And when we use this formula to calculate, and equals to 35. So the error is negative 1.5. Let's go to the eighth section, is introduction to random variables. This is our sample sample model is one repeated factor linear model. This is a table. So random factor is cities, thus uses another formula and reports on variability. Observed levels in the study represent a sample from all the possible levels. A second study will not use the same cities. We don't care about the degree to which city one differs from average. We simply remove city variability and get better F-test. If 3 cities are randomly selected from all cities, you hope to get a selection of cities like the ones to left cities are certain on the all-city average. Variability is still the inability process to repeat to its mean. But the mean for cities is the city average and not the overall mean of the data. Each time we do an experiment, we will pick up 3 different cities to use in our model. Select 3 cities at random from all cities. Just look at this map. 3 cities, another 3 cities. So although we cannot get an effect of the city, we assume the effect of city is normally distributed with mean as the mean equals to 0. We are interested in figuring out if the population of cities are different in sales and have big effect. We can see solid black line, or similar in sales and have a small effect, the dotted black line. If cities have big effect, they will reduce some square variable by a large amount. You can see these 3 curves. Or if cities have a small effect, are similar, and they will reduce some square variable by a small amount. You can see these 3 curves. So this is our hypothesis, H0 and HA. Okay, let's go to the next section. It's two-way mixed ANOVA, and then we have 1 fixed and 1 random variable. This is our matrix formula. The X is a design matrix, which means a matrix of values of X variables of a set of observations. Each row represents an observation. In the first column of the X matrix, it represents the intercept. Other columns represent value of X variable. Beta is a vector of estimate parameter which describes the fixed effects. 28 is intercept. 6 is the effect of being female. Z is a design matrix. It is analogous to the X matrix. It contains the predictions of the random effects. Gamma matrix describes the random effects for each city. The effect of Boston is to lower sales by 3.9423. And we can see the arrow is random matrix. We have 1 fixed variable, sex, and 1 random variable, city, in our model. We can use proglamix to have SAS output the X and Z matrix. We can use progmix to get SAS to output the beta and gamma matrix, and also the G matrix. If we have a repeating measures problem, we can use proglamix to have SAS output and R matrix. In the next example, we will use proglamix. We will discuss G matrix and R matrix in the next stream paper. This is our data. We use proglamix. And this is our matrix function. So first example is Boston female. And when we use a matrix formula, and we will get the predicted value. And when we compare the observed and predicted value, we will get the error. It's negative 1.55789. This is our second example, Washington, D.C. The value is 33.5. We also use our matrix function to calculate that. And we will get our predictive value, 34.9856. And when we compare between the observation and the predicted value, we will get the error is negative 1.4856. Thank you. That's it.